Thanks everyone for being here. I know there's lots of very interesting talks going on, so I appreciate your time and you showing up here. So today we're going to talk about native self-sovereign identity on Corda, and parts of this is joint work we have done with our three identity team, Abbas and Moritz here, and part of it is stuff that we have built on our own. I want to kind of quickly give a recap on where we are with digital identity. So over the evolution of internet identity, which began initially to mainly identify networks and machines on the network, was highly centralized. From there, we've gone through a phase of federation initiated by Microsoft Passport and technologies that came with that. And then over the last maybe 14 odd years or so, we have been moving towards more user-centric identity with the advent of OpenID, where people could even run their own, create their own provider service if they wanted, to OAuth and then to FIDO as various means of identifying, authenticating, and giving access to end users. Right? And so we are now entering a new phase of this user centricity that's self-sovereign. And that's where we want to talk about why we are doing so. So I see that more crowd has shifted here, so I'll spend some time this side of the Langton as well. So what are some of the challenges people face with digital identity, right? So as individuals, we find that we are very much not in control of our own identity and data, and that these credentials that we have been issued are highly issuer dependent. What happens to them, how they are managed, who gets to see them when they're compromised, what happens, all of this is highly issuer dependent. We also see a lot of fragmentation in our identity because we don't want to put all eggs in one basket. Sometimes there is no interoperability between providers, so we end up keeping pieces of our identity with different providers. And so since the fragmentation and centralization are not kind of antithetical to each other, because we have fragmentation across a few providers, and within those there is a lot of centralization of our attributes, right? So this poses its own risk. When a single Experian or a single Yahoo or Facebook gets compromised, millions and hundreds of millions of users' identities get compromised. On the flip side of this, what are some of the challenges businesses are facing with the digital identity today? So the number one thing is cost of verification, cost of identity management itself, right? And in part, this is due to the fragmentation we talked about. It's very difficult to get a complete picture of your customers, of your end users, of your employees, and so forth. And then there is the cost of compliance and cost of breaches. With more and more privacy regulation, personally identifiable data and identity attributes have almost become like nuclear waste, right, in some sense. You need to use this to fuel your business, but you also need to be very careful on how much you collect, what do you do with it, how do you store it, who do you share it with, and how can you delete it when the user no longer wants to be a part of your service. Right, so those are some of the challenges on the other side with the enterprises. So that kind of has been the driver with the emergence of this notion called self-sovereign identity. It is sometimes interchangeably, in this talk at least we'll refer to it interchangeably with decentralized identity, although there is a nuance you can argue on decentralized identities versus self-sovereign. There are some differences people argue on that. So about 2 years ago, led by the World Wide Web Consortium Identity Working Group, the W3C working group, a bunch of companies came together to create the Decentralized Identity Foundation to lay out the groundwork of standards and formats and so forth to what is known as self-sovereign identity, which are essentially decentralized identities anchored by blockchain IDs linked to zero trust data stores that are universally discoverable. That's the mission statement, right? Of this, I think we are kind of done with the first two, and maybe the third piece of this is along the way nicely. The universally discoverable part is still in the making, and interoperability is kind of one undisclosed segment there, which is very important for adoption. Right, so this is what self-sovereign identities are defined as. And why that is so, we'll come to that in a second. The blockchain, anchored in blockchain part is both for provenance, for trust, integrity, as well as for removing the dependence on a single provider, removing the dependence on a single point of failures for the users. So what self-sovereign identity allows users to do is to create and manage their own identities. And identities, maybe I should dive into that a little bit before going further. And identity is not just username and password, right? It's not just being authenticated to a web service and being given access to certain resources. We have different facets of our identity. We are citizen of a country, we are the resident of a city or town or village. We are employed by somebody, so there is a facet of our identity around that employment. We have certain level of expertise. We have certain creditworthiness in this society. We have bank accounts. We have library membership. We are members of professional organizations. Each one of these things, which we interchangeably call sometimes attestations or credentials, are very much a part of our identity. And when we refer to self-sovereign identity, it's not just about username, password. It's not just about your first name, last name, and date of birth. It's all of these elements of your identity. And with self-sovereign, the vision is users can authenticate to multiple web services without pre-registering, kind of like a global single sign-on with full control, without provider control. And then they can sign digitally verifiable transactions. And this is particularly the piece we are going to talk about is how this is possible on Corda Ledger natively as well. This is a visual representation of this. And this is one way of how self-sovereign identity can manifest. You'll have an app or a browser which manages your wallets, your keys, typically, that control the identity. So another important concept, PKI has existed for a long time, public key cryptography, right? And keys have often been used to identify entities and people. But one important concept here is with self-sovereign is decoupling your identity with the keys that manage and control that identity. Because you should be able to refresh your keys just like you refresh your passwords without having to let go of your identity and all the history associated with it. So that's one of the things SSI does. You basically can create your identity, register on a blockchain infrastructure. This can be a global public ledger because nothing personally identifiable ever gets stored on that in this architecture. Or it can be a consortium private ledger. It doesn't matter. And then there are verifiers and issuers who, issuers need to be also registered on this so they can issue credentials digitally to their end users. Like the stuff we talked about, whether you're a member of certain organization, you're employed somewhere, you have a credit rating with that agency and so forth. And then there are verifiers who don't need to be registered on the network, but need access to the blockchain infrastructure at least as a read-only access to verify the credentials presented to them. Right? So that's basically the structure. And this last piece here, the identity hub, is very important. So this identity hub is where the credentials, attestations, and the private keys also can be managed in full control of the user. The identity hub can be something that's on your phone, backed up transparently in your personal cloud, but fully encrypted on the client side. So there is no dependency, no visibility to the cloud provider or storage provider on what's inside it. You could run your own identity hub. The spec allows for that. Some people may choose to do that. Others may just depend on a cloud provider. Essentially, it gives you all of the benefits, the freedom of movement, I guess, all the time availability of these identity attestations without having to rely and giving up visibility to that cloud provider. So that's what the SSI picture looks like. So we're going to see a demo of all of this to make it clearer. But before that, all of this has been technical talk and reasoning behind this. But is there a business impetus behind all of this, right? So this is what the market seems to look like right now. So on the left-hand side, you see the hype cycle. And this time, Gartner has pulled out blockchain this year and made a whole chart about the different components and applications of blockchain. If you can see on the top left here, decentralized identity is right now peaking. And zero-knowledge proofs and distributed storage on blockchain, which are two of these technologies that kind of power self-sovereign identity, are also climbing up the hype cycle very much. And those are required to enable the vision of SSI. The one research by Markets and Markets says that this is just the blockchain and self-sovereign identity business would be about $2 billion worth by 2023. Gartner, the next two stats are from Gartner research. They predict that by 2022, 60% of blockchain consortium will be using self-sovereign identity. And not only that, But by a year later, almost 40% of all consumer initiatives, irrespective of whether they are blockchain based or not, are expected to use self-sovereignty. And like I mentioned at the start, right, there are two drivers to this simultaneously, or rather three things driving this. One is the technology is right there. Blockchain technology, zero knowledge proofs, practical, implementable, feasible zero knowledge proofs are here. The aspirations of the users in being able to control more of their identity, how it gets used, where it gets shared, particularly in light of all the data breaches that have been happening over the last decade, particularly in light of things like Cambridge Analytica and others, that those aspirations have grown. And the third driver is the regulatory driver. GDPR and CCPA have created huge privacy implications for enterprises and businesses in handling PII data. California is like the 6th largest economy in the world, I think, and then Europe with GDPR. Those two regulations themselves have created a huge business impetus for being innovative in handling this consumer data. Right, so those are the drivers that are causing all these markets to open up. And that leads us into what does this mean for Corda business users and Corda enterprise users, right? So what we have recently collaborated on with R3 and are unveiling at CordaCon, so to speak, is native support for this on Corda, right? So up until now, you had to run, let's say, an identity, self-sovereign identity network like an Indy in conjunction with Corda. We have jointly developed support for all of the W3C spec around DID creation, which is decentralized identifier creation, read, update, delete, all of those signs. And we have added support in Corda, in this service within Corda flows and Corda smart contracts to be able to recognize those digital signatures, those identities, and interact with business applications. End users can manage and create their identity in self-sovereign manner now, fully anchored on Corda Ledger, right? So that's the new thing we're talking about today. This is what the architecture looks like. You have, this is your Corda business network, the entire circle. There are a few nodes that anchor the identity. Now, in a smaller network, all of the nodes could potentially have the identity ledger or only a subset. These are what we call witness nodes. So what you get in the Corda service is essentially each of these nodes will run a Corda app and a web service. The web service will allow third-party applications to using standard REST APIs to interact with this service. And then on the other side, you'll have clients, mobile apps, browser-based applications, D apps, whatever can run that can utilize this service. Right? So a very important point here is that the stuff here in the blue rectangle, the trusted node, has been fully open sourced. It is W3C standards compliant. It is available on the R3 marketplace if you search for Corda DID method. That's the method. This is the joint work between R3 and Persistent Systems. This can be run on any public or consortium network to enable this identity service. It can support all of these CRUD operations and let you write client-side, create your own clients or use the clients that other people have made and integrate into your business applications. What would it take to integrate this into your Corda applications? You'll need some kind of a lightweight wallet implementation that can run on either clients' phones, in their browsers, or on their IoT devices, potentially. You will need support in all of that using the REST APIs to do all the CRUD operations that we talk about. What will be the change look like, right? So you have an IOU Corda app today, which is like a typical tutorial that R3 has put out. And Alice sends some IOU to Bob on the Corda ledger. What Alice is really doing is Alice is interacting with a node she trusts, a Corda node that she trusts, and has some identity management that the Corda node or a web service is doing for her, username, password maybe. She logs into that service, sends a request, and the Corda node signs that IOU transaction on the Corda ledger. On the other side, Bob, to approve that, does a similar thing, sends his approval to a Corda node who signs that on the Corda ledger on Bob's behalf. Right? This will change, can change with this new service. So this looks longer, but it's actually, the latency-wise, there's not much to add it there. but it gives more control to Alice and Bob on their identity. So in addition to the IOU application, there will be a DID registry, the witness nodes we talked about in the same network. This can, by the way, actually be a global independent network. It doesn't have to be on the same network. Alice and Bob would have DIDs on this, and they'll be managed on their phones. So when Alice signs an IOU transaction, she's signing that on her phone with a DID and a private key that she controls, right? And that's being sent through and through the Corda node of the institution she does business with. And that institution will send that to a Corda flow, which can verify both the node signature, like Corda does, but can also verify Alice's signature by doing a lookup on the DID registry, and then send it to the ledger. So the ledger will contain both signatures now, the node signature and Alice's signature for the record, right? And similarly, on the other side, Bob approves. He's signing the transaction from his phone that's going all the way through the flow and contract and residing on the ledger. So you have end-to-end accountability of that IOU piece. So this is the technical part of it. What would the user experience of this look like? And what can you really do with this technology, right? So this is much more than just doing this kind of transactions. It's about empowering the users to build and compose their identity through like Lego-like building blocks, and start engaging with more and more digital services. So let me switch to a demo live. So here we go. I have an app that's called Signa right now, which we have built at Persistent. This app, I'm just going to get started and create a new identity. The demo is catered for John Smith, but other than that name being used, everything else is like standardized web services that we're running using SDKs that we have created. So nothing is hard-coded per se. So I'm just going to go ahead and say create identity. Oh, I forgot to take a picture, but I could have put my profile in there. So this is what I get, right? So and you saw how fast that was. So this is talking to a Corda identity network, a testnet that Persistent has set up. It has created this identity DID, as it's called, which is the W3C spec for creating decentralized identities. It has bootstrapped a public and private key pair right on my phone, right? And this is using the same RFC and wallet technology, like something called hierarchical deterministic wallets that the best state-of-the-art Bitcoin wallets and Ethereum wallets are using. And so they use a seed phrase and all of that. So you can have a recovery mechanism independent of a provider, because there is no service here that is going to help you when you forget your password or you lose your keys. So you have to bake it into this user experience, right? So this public key, if you see, there's a refresh keys option there. The refresh keys options can be used to refresh my key pairs, public and private key pair, in case I compromise it. So you can have different key pairs controlling that same identity. We have built-in support for backing up all your credentials and attestations. In case you lose your phone, you don't want to lose all of your attestations. So there is support for the standard cloud drives. The difference is all of the data gets encrypted on your phone before it gets backed up seamlessly each time you receive an attestation once you enable this. In the future, we think that this would be, you could plug in, by the way, IPFS, which is a distributed decentralized file system. This support is there built in right now. And we can, if I have time, I can even show how recovery works. But let me go ahead and start showing what a user can do with this. And so in this demonstration, this user, John Smith, is logging into the State Department website, which issues passport, right? I think in the UK, it's called the Home Department. Incidentally, for brevity, we have also made John an employee of the State Department. So he goes in, logs into their portal, which is where he already has a username password. This is how we are showing how bootstrapping will happen, right? And State Department is supporting this Signa wallet. So I'm just going to go ahead and connect my DID to my logged in identity. And so I get a pop-up that's saying so-and-so entity, Department of State, is asking for my identity information. There's nothing PII or personally identifiable in this information. It's just my DID. And because they know I have logged in, they know that this ties to the JSmith login that's with them. So I accept it. It asks for a biometric confirmation on my phone, goes through. I have connected my DID. Now I can digitally receive both my employment information and my personal information, like passport details and so forth, from this particular service, right? So that's again simple QR code scanning. We can also do this through push notifications, whichever user experience works best. So this is telling me that I'm getting 2 credentials or 2 attestations being issued to me. So I accept them, and you'll see that they are both on my device. It has my name, my salary and designation, all of that, and the issuer details, which my app is verifying by, again, querying the DID registry that we talked about and making sure that it's talking to the right server. It also has my name, address, phone number, social security number, all of that detail certified by the State Department. Now we chose State Department because when we see the next step, typically for composing these identities, you'll have to bootstrap with some government issued identity. So the next one is I want to get my driver's license, right? And my motor vehicle record that's registered with the Department of Motor Vehicles. They support now sign in with Cigna. One of the issuers they trust for basic identity is Department of State. So I log in there, I just connect this, scan this, and it's saying for DMV to identify me in their web service, they need certain pieces of data. The wallet is looking at the schema, intelligently picking up the right attributes from the right attestation. So one of the things here is the composability of your identity attributes. So you don't have to share an entire driver's license with somebody if all that they need is just your address proof. You can just pull out that address and the wallet will help you share it. I can even choose not to share anything by just disabling those if they are optional, and I go ahead and say allow, right? So at this point, I have provided certain details for DMV to identify me in their database, and immediately they pull up my records, right? And here they have a lot more info about me. They have my height, my weight, color of my eyes, and they have my vehicle information. Now they're going to issue me these credentials, and you'll see why all of this matters in the last step. So they're going to issue me these things, and so far all of these things are just standard digital services. There's no Corda app running behind this, right? So I accept this, and then I move to the next step, which is now I want to go into an insurance marketplace and apply for car insurance. Now in this instance, for demo purposes, this is a Corda-based application running. Imagine this is an insurance marketplace. And just to get a quote, I don't need to share everything about me to get a quote. I just need to prove the state I'm a resident of, the zip code I'm living in, and driver's license information and my vehicle information, right? So instead of filling out a huge form and uploading a bunch of PDFs, I can digitally share these. And if you see, there's a lot of information on this. I can digitally share a lot of this by just clicking on scanning this QR code and providing this information. So this will, okay, hold on. I don't know why it's taking some time. So this is again pulling up a lot of these attributes from different pieces. What you'll see here, what is interesting here is these last 2 items, age and salary, right? So since I am not yet ready to do the contract, I don't need to give them my exact date of birth. All I have to prove using zero knowledge proofs, my age. And that's what you'll see, this little blue icon that appeared. We just computed a zero knowledge proof verification, or sorry, a proof to be presented to this particular verifier. And same with my salary. Instead of giving my exact salary, I'm able to prove a range proof that it's between 50,000 and 100,000 without actually having to reveal that. So this is computed live. And I'm going to go ahead and share this. Once I share this, this proof is submitted not only to the web service, it can be checked on in the Corda flow and on a Corda smart contract, and the insurance company can generate a quote for me and a contract. So I'm going to just go ahead, it pre-filled all that information, I'll submit it, and right there, it looked through all this, verified my signature and generated a contract for me. So I'm now going to sign that contract, and this signature is again going to be registered on the ledger. So I've got a full insurance policy. I can save this and sign this. So at this point, my private key that is controlling the DID is signing this PDF and agreeing to a particular insurance contract, and that's being behind the scenes checked on the Corda ledger. Right, so that's our end-to-end demonstration of what this technology is capable of doing. There is not only zero knowledge proofs. If you see in this architecture, whenever I'm presenting these credentials to somebody, like the DMV, the issuer of that credential doesn't know who I'm presenting this with, and that's the additional transactional privacy we have in this system. I want to leave you with this one thing, which is this is what the capabilities that we just saw: creating identities, managing digital credentials, single sign-on like capability, composing your identity slowly so you don't need everything to be in place on day one, user control privacy, selective attribute sharing, privacy against from the issuers in where you're sharing this, and then zero knowledge proofs that prove things about you without having to reveal personal information, automatic backup and sync, easy recovery, right? So all of that is baked in, and this is something which can be white labeled entirely for your business needs. So that's it from me. Thank you. Any
All right.
questions?
We have lots of really, really good questions, but we only have 3 minutes, so I'm really, really sorry if I can't get to your question. So the first one says, with identity being such an important aspect of life, what are the main pushbacks we're seeing from enterprises not to apply a self-sovereign service?
So I think it's not so much a pushback as to enterprises are going through an education phase. Enterprises are struggling with traditional identity management. If you think of a global conglomerate who has gone through multiple mergers and acquisitions globally, there's maybe 20 traditional identity systems they're struggling to integrate with and keep business running as usual. So enterprises are right now learning, educating themselves, experimenting and piloting with this. This has to simultaneously have the support from the government sector. A lot of identity is bootstrapped through government-enforced identification. So, the regulatory support, the government's support, and the enterprise ability and appetite to understand and experiment is what is going to drive adoption. Yeah.
Okay. And how do you manage and verify revocations?
Yeah, so the way revocations work is the credentials themselves are anchored through a zero knowledge proof into the ledger. And so when you receive a credential, you're not only verifying who has issued this, but you're also verifying on the blockchain whether this credential has been revoked or is still valid. This entire verification can be done without storing personally identifiable information, or even it's not even a plain hash, because there are rules around privacy in GDPR where you can't just hash PII and put it. So there is specific zero knowledge proofs that are in use, pioneered by the Sovereign Foundation, that are being adopted elsewhere as well, on proving existence and validity of credentials that have not been revoked without putting them on the blockchain. Yeah.
Do you think Corda is ready to handle the number of users, accounts, and wallets it would need to support a real-life global DID network?
You bet, right? Right about So, that's the short answer. But hey, yeah? Yeah, it's the only answer, because that's a pretty menacing statement. But yeah, it is the only answer. In fact, this particular solution, right? If I was at an event recently where Corda business applications were talking about, if you want to map hundreds and millions of users into Corda applications, and if you want to represent each of them with a native identity, it would have to be the Corda node identity. And that's not practical when you're talking about hundreds of millions of devices, for example, going online. When you're talking about hundreds of millions of users being represented as first-class entities or citizens on the Corda ledger, this is the way to go forward.
One of the principles of SSI states users must have an independent existence.
Yes.
Do you see this being possible on a permission network like Corda, where we have dependency on a membership service or authority?
So a membership service doesn't negate the principle. I think this was one of the principles, if I'm not mistaken, Christopher Allen, who I referenced, had talked about independent existence, right? We will exist independently of whether we are a member of a Corda network or not. I think what we have here is not only representing end users, but there will be the different question to think about would be, there would be devices and entities that are non-living that would be in this ecosystem, and how would they be represented? And that's where the hierarchical deterministic wallet we talked about allows us to create multiple DIDs for all the things that belong to a human, and have that relationship of control with a different key between DIDs, so to speak. So I can have my car registered with its own DID, but then I can be the controlling DID for that and so forth. So that's what this technology supports.
All right, thank you. Can we have
Thank you.
another round of applause?